A very good evening to everyone. My name is Sanjana Gulaya, and this is my video for the second task that was given to me as a data science and business analytics intern at the Sparks Foundation. The objective of this task was to use an unsupervised machine learning algorithm to predict the optimal number of clusters and represent this visually given the iris dataset. So in this case, I've used k-means clustering, which is an unsupervised machine learning algorithm, to do the same. And the code for this project is also available in my GitHub repository, for which I've included a link over here. And I've also included a QR code which you can scan and it will take you to my repository page. Now I'll quickly jump to the Jupyter Notebook where I've performed the code and I'll just go through it. So firstly, going through all of the imports that we have NumPy and pandas as basic data reading and manipulation libraries. And then for data visualization, we have matplotlib and seaborn. I've also included a line which is matplotlib inline over here. Basically what it ensures is that I don't have to use the dot show method every time I plot something. It's automatically visible within the Jupyter Notebook itself. So starting off with the code, the CSV file that was given to us as a data set was called iris.csv. So we've read that using the pd.readcsv method. And I'll take you to the dataset over here just to give you a rough idea as to what we're dealing with. Mainly we have 4 features over here: sepal length, sepal width, petal length and petal width, all of which are in centimeters. And based on these 4 features, we're classifying the iris flower into 3 categories, which is iris setosa, iris versicolor, and lastly we have iris virginica. So in the CSV file, as we can see, there are 150 samples, and our aim is to basically classify these 150 samples into an optimal number of clusters. So we quickly just check the head of the data frame over here. As expected, we have 4 features and then we have the species column. ID over here will not really be considered a feature because it's basically just the serial number of all of the 150 samples. What we do next is we divide the data frame into 2 parts: X, which contains basically all the data from all the features, and Y, which is the species column. So that's something we aim to classify the iris flower into the 3 categories. Now the deal with k-means clustering is that before we actually perform the algorithm, we need to know the number of clusters beforehand. So in this case, what we do is we use the elbow method to find out the optimal number of clusters. In this method, we find the sum of squared errors for a range of cluster numbers, and then we plot the sum of squared errors against the cluster numbers to get a graph. And basically, I'll just show you the graph. So this graph that we get is something that's identical to a human arm, and then what we see as the elbow point on a human arm is what we can consider to be the optimal number of clusters. So we quickly just going through the code. We have to import k-means from sklearn.cluster, and then what we do is we define range as the range from 1 to 10, and then we have initialized an empty list over here, which is known as sum of squared errors. So basically next what we have is we have a for loop, and in each iteration of the for loop we create a model of k-means known as km, and km is basically dependent on the number of clusters. So in each iteration the number of clusters is taking the value of I. Over here that would be from 1 to 10. What we do next is we fit the model according to the feature data, which is X over here, and then we append the sum of squared errors to the empty list sum of squared errors. We get the sum of squared errors using the method km.inertia. So this returns the sum of squared errors for the model km for that particular iteration. What we do next is we just plot the range 1 to 10 and the sum of squared errors using PLT. We've also just done title, X label, Y label to give like a bit of clarity to the graph. So as you can see, we've received this graph over here, which is identical to the shape of a human arm, and the elbow point over here can be identified as 3. So we can conclude that the optimal number of clusters in this case is 3. So what we do next is we perform k-means clustering with the number of clusters that is known to us now equal to 3. So we create a new model which is known as k-means_3. I've just named that over here, and we give n clusters equal to 3 in this case. Again, what we have to do is we have to fit the model with the data X over here. Now we can call a number of methods from k-means_3. So over here what I've done is I've called cluster centers and I've printed this out. So we have the new cluster centers, and we can also then find out the predicted clusters after k-means clustering using the .fit_predict method, which we input the data X into, and therefore we receive the predicted clusters. I've printed that out over here as well. It's this NumPy array, and This is what we've got after k-means clustering. So next what we do is we basically visualize the clustering. What we use over here is a scatter plot from matplotlib, and based on the first two columns, we given C as the predicted clusters, and C map over here is basically the color map. In this case I've used Viridis, we could have used any other color map, and I have plotted out the scatter plot. So as you can see from this graph, we have successfully classified all of the 150 samples into 3 clusters, which are separate from each other, and they're visible as purple color, yellow color, and blue color. And therefore k-means clustering has been successfully performed, and we have identified the optimal number of clusters as 3. So that's it for this task. Thank you very much.